ವೆಲ್ಕಮ್ ಟು ಅವರ್ ಪೀಸ್ ಆಫ್ ಲರ್ನ್ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್. ನೀವು ನಮ್ಮ ಚಾನಲನ್ನು ಸಬ್ಸ್ಕ್ರೈಬ್ ಆಗಿಲ್ಲ ಅಂತಂದರೆ ಈ ಕೂಡಲೇ ಸಬ್ಸ್ಕ್ರೈಬ್ ಆಗಿ ಮತ್ತು ಬೆಲ್ ಐಕನ್ ಮೇಲೆ ಕ್ಲಿಕ್ ಮಾಡೋದನ್ನು ಮರಿಬೇಡಿ.
ಇವತ್ತಿನ ವಿಡಿಯೋನಲ್ಲಿ ನಾನು ನಿಮಗೆ ಸಿಂಗ್ಲಿ ರೀಇನ್ಫೋರ್ಸ್ಡ್ ಬೀಮ್ಸ್ ಮತ್ತು ಡಬ್ಲಿ ರೀಇನ್ಫೋರ್ಸ್ಡ್ ಬೀಮ್ಸ್ನ ಹೇಗೆ ಡಿಸೈನ್ ಮಾಡೋದು ಅಂತ ಪ್ರೊಸೀಜರನ್ನು ತಿಳಿಸ್ಕೊಡ್ತಾ ಇದ್ದೀನಿ. ಸ್ಟೆಪ್ಸ್ ಫಾರ್ ಸಾಲ್ವಿಂಗ್ ಅಲಾನ್ ಅನಾಲಿಸಿಸ್ ಪ್ರಾಬ್ಲಮ್ಸ್. ಟೈಪ್ 1 ಗಿವನ್. ಟೈಪ್ 1 ಪ್ರಾಬ್ಲಮ್ ಇದು. ಗಿವನ್ AST or number of bars with diameter of bars, size of beam, grade of concrete of steel. If load to be calculated, then span is given. ಗಿವನ್ ಇಷ್ಟು ಕೊಟ್ಟಿರ್ತಾರೆ. ರಿಕ್ವೈರ್ಡ್ ನಾವೇನು ಕಂಡುಹಿಡಿಯಬೇಕಾಗಿರುತ್ತೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳೋದಾದರೆ ಅಲ್ಟಿಮೇಟ್ ಮೂಮೆಂಟ್ ಆರ್ ಫ್ಯಾಕ್ಟರ್ಡ್ ಮೂಮೆಂಟ್ ಆರ್ ಮೂಮೆಂಟ್ ಆಫ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಆರ್ ಸೂಪರ್ ಇಂಪೋಸ್ಡ್ ಲೋಡ್, ಇಷ್ಟನ್ನು ನಾವು ಕಂಡುಹಿಡಬೇಕಾಗಿರುತ್ತೆ. ನೋಟ್: ಅಲ್ಟಿಮೇಟ್ ಮೂಮೆಂಟ್ ಅಥವಾ ಫ್ಯಾಕ್ಟರ್ಡ್ ಮೂಮೆಂಟ್ನ ಹೇಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ ಅಂದರೆ 1.5 ಇಸ್ ದ ಫ್ಯಾಕ್ಟರ್ ಆಫ್ ಸೇಫ್ಟಿ ಇಂಟು ದ ವರ್ಕಿಂಗ್ ಮೂಮೆಂಟ್ ನಮಗೇನು ಸಿಕ್ಕಿರುತ್ತೆ ಅದರಿಂದ 1.5ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತೀವಿ. ಬಿ, ಅಲ್ಟಿಮೇಟ್ ಲೋಡ್ ಆರ್ ಫ್ಯಾಕ್ಟರ್ಡ್ ಲೋಡ್ 1.5 ಇಂದ ಮತ್ತೆ ವರ್ಕಿಂಗ್ ಲೋಡನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತೀವಿ. ಐದರ್ ಮೊಮೆಂಟ್ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಬೋದು ಅಥವಾ ವರ್ಕಿಂಗ್ ಲೋಡನ್ನಾದರೂ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಬೋದು. ಸ್ಟೆಪ್ 1, ನೋಟ್ ಡೌನ್ ದ ವ್ಯಾಲ್ಯೂಸ್ ಫಾರ್ XU by D, XU max by D by referring IS 456-2000 ಪೇಜ್ ನಂಬರ್ 70. FY ವ್ಯಾಲ್ಯೂಸ್ ನಮಗೆ ಕೊಟ್ಟಿರ್ತಾರೆ. 250, 415 ಗ್ರೇಡ್ ಆಫ್ ಸ್ಟೀಲ್ ಇದು. 250, 415, 500. XU ಮ್ಯಾಕ್ಸ್ನ ವ್ಯಾಲ್ಯೂ, XU max by D ವ್ಯಾಲ್ಯೂ 250 ಗ್ರೇಡ್ ಆಫ್ ಸ್ಟೀಲ್ಗೆ 0.53, 415ಗೆ 0.48, 500ಗೆ 0.46. ವೇರ್ FY ಅಂದರೆ ಏನಂತಂದರೆ ಈಲ್ಡ್ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ಸ್ಟೀಲ್. ಸೆಕೆಂಡ್ ಸ್ಟೆಪ್, ಡಿಟರ್ಮೈನ್ ಡೆಪ್ತ್ ಆಫ್ ನ್ಯೂಟ್ರಲ್ ಆಕ್ಸಿಸ್. ಡೆಪ್ತ್ ಆಫ್ ನ್ಯೂಟ್ರಲ್ ಆಕ್ಸಿಸ್ನ ಹೇಗೆ ಕಂಡುಹಿಡಿಯೋದು ಅಂದರೆ XU by D ಪೇಜ್ ನಂಬರ್ 96 ಆಫ್ IS 456-2000 ಅಲ್ಲಿ ಈ ಫಾರ್ಮುಲಾನ ಮೆನ್ಷನ್ ಮಾಡಿದ್ದಾರೆ. XU by D is equal to 0.87 FY AST divided by 0.36 FCK BD. FY ಅಂದರೆ ಗ್ರೇಡ್ ಆಫ್ ಸ್ಟೀಲ್, FCK ಅಂದರೆ ಗ್ರೇಡ್ ಆಫ್ ಕಾಂಕ್ರೀಟ್. FCK that is characteristic strength of concrete, that is M20 ಗ್ರೇಡ್ ಆಫ್ ಕಾಂಕ್ರೀಟ್ ನಾವು ತಗೊಂಡಿರೋದು 20 Newton per mm square. 25 Newton per mm square for M25 grade of concrete, and B is the breadth of beam, D is the effective depth of beam or overall depth of beam minus effective cover. effective cover ಹೇಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು ಅಂದರೆ ಕ್ಲಿಯರ್ ಕವರ್ ಪ್ಲಸ್ ಡಯಾಮೀಟರ್ ಆಫ್ ಬಾರ್ ಡಿವೈಡೆಡ್ ಬೈ 2. AST ಅಂತ ಅಂದರೆ ಏರಿಯಾ ಆಫ್ ಟೆನ್ಸೈಲ್ ರೀಇನ್ಫೋರ್ಸ್ಮೆಂಟ್, ಆರ್ ದಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ನಂಬರ್ ಆಫ್ ಬಾರ್ಸ್ ಇಂಟು ಪೈ ಇಂಟು D ಸ್ಕ್ವೇರ್ ಬೈ 4. D ಅಂದರೆ ಏನು ಅಂದರೆ ಡಯಾಮೀಟರ್ ಆಫ್ ದ ಬಾರ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೀವು 8 mm ಬಾರ್ ತಗೊಳ್ಳೋದಾದರೆ ಇಲ್ಲಿ ಡಯಾಮೀಟರ್ ಜಾಗದಲ್ಲಿ 8ಅನ್ನು ಸ್ಕ್ವೇರ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. 12 mm ಬಾರ್ ತಗೊಳ್ಳೋದಾದರೆ 12ಅನ್ನು ಸ್ಕ್ವೇರ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಸೊ ಕಮಿಂಗ್ ಟು ದ ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್, ದಟ್ ಈಸ್ ಸ್ಟೆಪ್ 3, ಕಂಪೇರ್ XU by D ಆ್ಯಂಡ್ XU max by D ratios. ಇಫ್ XU by D is lesser than XU max by D, section is under reinforced. ಈ ಕಂಡೀಷನನ್ನು ನೀವು ತುಂಬ ಕ್ರಿಟಿಕಲ್ ಆಗಿ ನೋಡಬೇಕಾಗುತ್ತೆ. XU by D is lesser than XU max by D, so section is under reinforced. Therefore, calculate the moment of resistance by the following expression. The following expression is given in page number 96, that is mu is equal to 0.87 FG AST D into 1 minus AST FY by BD into FCK. ನೆಕ್ಸ್ಟ್ ಕಂಡೀಷನ್ನ ನೋಡೋದಾದರೆ ಇಫ್ XU by D is greater than XU max by D, section is over reinforced. ಅಂಡರ್ ರೀಇನ್ಫೋರ್ಸ್ಡ್ ಮತ್ತು ಓವರ್ ರೀಇನ್ಫೋರ್ಸ್ಡ್ಗೆ ಡಿಫ್ರೆನ್ಸನ್ನು ಇಲ್ಲಿ ನೀವು ತಿಳ್ಕೊಬೇಕಾಗುತ್ತೆ. ದೇರ್ ಫೋರ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ಲಿಮಿಟಿಂಗ್ ಮೊಮೆಂಟ್ ಆಫ್ ಇನ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಬೈ ದ ಫಾಲೋಯಿಂಗ್ ಎಕ್ಸ್ಪ್ರೆಷನ್. MU ಲಿಮಿಟ್ ಫಾರ್ಮುಲಾನು ಕೂಡ ಕೋಡ್ ಬುಕ್ಕಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ, ದಟ್ ಈಸ್ IS 456-2000. MU ಲಿಮಿಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 0.36 XU max by D 1 minus 0.42 XU max by D into BD square by FCK into FCK, or by substituting the values of XU max by D in the above equation. The equation we will get by simplifying the formula is mu limiting is equal to 0.149 FCK BD square for Fe 250 grade of mild steel, and mu limiting is equal to 0.138 FCK BD square for Fe 415 grade of steel. Mu limiting is equal to 1.133 FCK BD square for Fe 500 grade of steel, that is HYSD bars. Next step, to calculate safe Udl, that is UDL means UDL or live load. Moment of resistance MR is equal to mu by 1.5. mu na ನೀವು ಮೇಲ್ಗಡೆ ಈಕ್ವೇಶನ್ ಅಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿರ್ತೀರಾ ಕೊಟ್ಟಿರೋಂಥ ಗ್ರೇಡ್ ಆಫ್ ಕಾಂಕ್ರೀಟ್ಗೆ. ಸೊ ಈಕ್ವೇಟಿಂಗ್ ದ ಮ್ಯಾಕ್ಸಿಮಮ್ ಬೆಂಡಿಂಗ್ ಮೂಮೆಂಟ್ you will get from calculating the moment of resistance. So bending moment will be attained from the moment of resistance. The moment of resistance for simply supported beam carrying UDL. So there is a standard formula for the bending moment for simply supported beams. M is equal to WL square by 8. So equating this equation, M is equal to MR is equal to WL square by 8. So total load will be W is equal to 8 MR by L square. But total load W includes self weight of beam plus live load, where self weight of the beam can be calculated as breadth into depth into density of RCC. P is equal to 25 kilonewton per meter cube and D is equal to overall depth of the beam. Therefore, live load or superimposed load or safe UDL can be calculated. W minus self weight of the beam. This is for the live load or superimposed load. Note for the first type of problem, if cantilever beam carrying UDL given, then maximum bending moment M will be WL square by 2. If the cantilever beam carrying UDL with self weight plus point load at free end, then maximum bending moment M will be WL square by 2 plus WL. Third condition, if simply supported beam carrying UDL where it includes self weight plus central point load given, then the maximum bending moment will be M is equal to WL square by 8 plus WL by 4. These are the three main conditions for the type 1 problem. Coming to the type 2 problem, the given factors are factored or ultimate moment MU or moment of resistance M or total load plus span with type of support, size of beam, type of steel and concrete. ಇದನ್ನೆಲ್ಲ ಅವರೇ ಕೊಟ್ಟಿರ್ತಾರೆ given in the question, and what do you require to find from these given elements is area of tensile steel, that is AST. So coming to the step 1 of the solution, if load W and effective span L is given, then calculate the maximum bending moment. The bending moment formulas are standard for simply supported and cantilever beams carrying UDLs. For simply supported beam it is the M is equal to WL square by 8, and for cantilever beams carrying UDL M is equal to WL square by 2. So ultimate moment can be calculated by using the formula mu is equal to 1.5 into M, that is the moment which you have calculated in the above step. Second step, equate ultimate moment to moment of resistance. This is the standard formula which is given in the code book of IS 456-2000. mu is equal to 0.87 Fy AST into D 1 minus AST Fy by BD into FCK, where Fy is the grade of steel, AST is the area of steel, and Fy is, as I have before mentioned, Fy is the grade of steel and FCK is the grade of concrete. Solving the quadratic equation, we can get the value of AST and calculate the number of bars. Beams. Doubly reinforced beams includes both tensile reinforcement as well as the compression reinforcement. Singly reinforced beams will carry only compression reinforcement, not tensile reinforcement. The same compression reinforcement will be acting as if it is also meant for tensile as well as compression, but there will be only one single reinforcement, that is compression. In doubly reinforced beams, both compression steel and tensile steel will be acting. So coming to the problem, steps for solving analysis problems given. AST will be given, that is area of steel. ASC will be given, that is area of compression reinforcements, and size of beam, effective cover for compression steel, that is D dash. Type of concrete and steel will be given. If load to be calculated, then span will be mentioned or given, or you can assume the span. Required. What do you require to find out from the given elements, that is ultimate moment or factored moment of resistance or superimposed load, that will be denoted by small w. So coming to the steps which you need to follow for calculation of these problem. ASC. How do you calculate ASC? Number of bars into pi into diameter of the bar, that is sigma c or phi c whole square by 4. that will be in mm square. So calculate AST, number of bars into pi d square by 4, that will be in mm square. Calculate XU max is equal to 0.48D for Fe415 grade of steel. XU max is equal to 0.53D, that is Fe250 grade of steel. All these values or formulas are mentioned in the code book as I have mentioned in the previous problem. So coming to the third step, that is strain in compression steel. How do you calculate strain in compression steel? That is ESC is equal to 0.0035 into XU max minus D dash by XU max. This formula is given in the code book of IS 456-2000 in clause number 1 G 1.2. Knowing the strain, the stresses compression steel FSC can be obtained from steel strain curve of corresponding steel or form ROM from SP16 table number A. As I have mentioned SP16 table number A, I have given the description of the table for FE 415 grade of steel and FE 500 grade of steel, and the stress levels are also been mentioned 0.80 FYD, and all the calculations have been mentioned for stress and strain. Stress in Newton per mm square and strain doesn't have any unit, so all these values are mentioned, and you can interpolate the values if you get in between values for stress and strain curves, and the linear interpolation may be done for intermediate values also. Or you can carry out this for stress in compression steel, or you have another step to be done. This is an OR step. From the following table of F of Fe16, SP16, strain in compression steel FSC Newton per mm square, there is another table mentioned also, grade of steel, that is D dash by D ratio. For Fe 415 grade of steel and Fe 500 grade of steel, it has been mentioned. You can take these values also for the interpolation or for the compressive steel of strain calculation. For example, if D dash by D is equal to 0.11 from the table F by linear interpolation, we get it as, you can take the values for Fe 415 grade of steel. For 0.10, there is a 353 is the value of, what do you say, XU max. So you can take those values and then interpolate the in between values, and you will get the value as 350.8 Newton per mm square. Please note, for mild steel Fe250, FSC is equal to 0.87 of Fy. Coming to the fourth step, depth of neutral axis. AST2 is equal to ASC into FSC. This is a standard formula, ASC into FSC divided by 0.87 of Fy. After calculating this AST2, you can summate the two ASTs. AST is equal to AST1 plus AST2, or AST1 is equal to AST minus AST2. So XU by D formula, as I mentioned in the previous step or previous problem also, this is a standard formula, or depth of neutral axis can be directly computed. By using the following relation, XU can be determined. XU is equal to 0.87 Fy into AST minus FSC into ASC divided by 0.36 FCK into B. If XU is lesser than XU max section, then it is called as under reinforced section. Therefore, calculate the moment of resistance by the following expressions as mentioned below. These three are the following expressions. You can take down these expressions and calculate the moment of resistance. Or there is another step also which you can be calculating. Mu is equal to 0.36 FCK BXU D minus 0.42 XU plus FSC AAC D minus D dash, where if XU is greater than XU limiting section, then it is over reinforced section. The reinforcement given is over, that is, it has exceeded the limit of reinforcement. Put XU is equal to XU limit value and calculate the moment of resistance by the following expression. These are the following expressions for Fe 415 grade of steel, Fe 250 grade of steel. You can be calculating the Mu limiting. To calculate safe Udl of live load, follow the same steps as in the singly reinforced beams. I have mentioned in the previous for the singly reinforced sections or beams, you can follow the same procedure to calculate safe Udl of live load. Type 2 type of problems. Given data is factored moment or moment of resistance or total load plus span will also be given with type of support, size of beam, D dash type of steel and concrete. required AST and ASC. Steps: if load W and effective span L is given, calculate the maximum bending moment. Maximum bending moment formula for simply supported beam is very standard, as I mentioned before, WL square by 2 for cantilever beams and WL square by 8 for simply supported beams. Then you have to factor the moment which you have obtained by multiplying it by factor of safety, that is 1.5. Find the limiting moment of resistance. Mu limiting is equal to 0.149 FCKBD square, that is for Fe 250 grade of steel, and Mu limiting is equal to 0.138 FCKBD square, that will be for Fe 415 grade of steel, that is HYSD bars, and Fe 250 is for mild steel. Mu limiting or Mu is greater than Mu limiting, then the beam is designed as doubly reinforced beams, which I have mentioned before. Doubly reinforced beams will have both compression and tensile reinforcements. So we have to calculate both the reinforcement over here. Area of compression steel will be calculating first, that is ASC. Finding the FSC value as explained in the type 1 problem, Mu minus Mu limiting is equal to FSC into ASC D minus D dash. ASC can be calculated by the given standard formula in IS 456-2000. ASC is equal to Mu minus Mu limiting divided by FSC into D minus D dash. Coming to the fourth step, that is area of tensile reinforcement, AST1 is equal to 0.36 FCK BXU max divided by 0.87 F. This is the standard formula for calculating AST1, which you have to remember. It is not mentioned in the codebook. AST2 is equal to ASC into FSC divided by 0.87 Fy. For calculating or summating both the ASTs, we'll get the reinforcement details, which you need to be mentioned in the doubly reinforced beams. AST is equal to AST1 plus AST2. By getting the AST, you should have to calculate the number of bars which you have to place and the spacing in between them.
ಕೀಪ್ ಸಪೋರ್ಟಿಂಗ್ ಅಸ್. ಲೈಕ್ ಮಾಡಿ, ಶೇರ್ ಮಾಡಿ, ಮತ್ತು ನಿಮ್ಮ ಅನಿಸಿಕೆಗಳನ್ನ ಈ ವಿಡಿಯೋ ಬಗ್ಗೆ ಕಮೆಂಟ್ ಬಾಕ್ಸ್ನಲ್ಲಿ ತಿಳಿಸಿ. ಥ್ಯಾಂಕ್ಸ್ ಫಾರ್ ವಾಚಿಂಗ್.